last class, we kind of stepped up to the pre-algebra side of things with the order of operations. Hopefully that review helped us a little bit. And then, of course, I'm using formulas, evaluating expressions, then based on order of operations. Today, we're going to move into percents. And we're going to take a couple of days on percents. We're going to introduce it today, and then in Unit 2, we're going to come back to it in more detail. Because there's a lot of applications in percents in medical math and other applications that I think is very important for you to see just on the medical side of things, and then also important just from being a young consumer side of things that are important to applying to your everyday life. So for right now, we're going to talk about the basics of percents. And to understand percent, you need to understand the word percent. It's actually two words, per and cent. So per, if you think of miles per hour or miles per gallon, it means like for each or out of. Cent, if you think of years in a century or cents in a dollar, that means 100. So percent literally means out of 100. So when you see that percent symbol, that's what it is telling you. So if we have 38%, that means 38 out of 100. It's a ratio. Now, the next few things I'm going to show you are things that you have seen, but the language and terminology you've seen is most likely technically incorrect. So what we did here is we converted our percent into a ratio. And as a ratio, it looks like a fraction. And a lot of textbooks and a lot of teachers will say that's the fraction form of a percent. But it really is not a fraction. It is, as we called it before, a ratio. It's a comparison of two numbers. Now we can reduce it similar to the way we would a fraction. Both 38 and 100 are divisible by 2, giving us 19 over 50. Now again, we often call that the fraction form of a percent, but again, it is technically a ratio. So putting it in ratio form or reduced ratio form or fraction form mean the same thing, but like I said, it really is a ratio, even though that terminology of fraction gets used a lot. We're not going to waste a lot of time with simple percents going into fractions. We're going to look at a couple of the more difficult conversions just to make sure you recall how to do those. Something like 265%. If I want to put that into ratio form or fraction form, it of course starts out as 265 out of 100. All percents, the symbol percent means out of 100. So it will always be out of 100 like this in the first step of converting. Now, of course, first of all, this is an improper fraction. The numerator is bigger than the denominator. And at this point would probably be the easiest point to convert it into a mixed number because it's out of 100. We know that 100 goes into 265 twice with 65 left over. So that's a pretty easy division and remainder to convert that into the mixed number. Now we do have to reduce that fraction form of 65 over 100. Both of those can divide by 5. So 65 divided by 5 is 13, and 100 divided by 5 is 20. Then, of course, we still have the 2 on front. So the fractional form, or the ratio for 265%, is 2 and 13/20. Now, one thing, when we actually talk about ratio and proportion directly in Unit 2, we will talk about most of the time we avoid reducing a ratio into a mixed number like that. We tend to leave it as an improper fraction. But in percent applications, for some reason, we choose to reduce that into a mixed number rather than leaving that as 53 over 20. We might have something like 56.25%. Again, converting it into a ratio or into that fractional form, it is 56.25 over 100. Now, we do not like having decimals within our ratio, within our fraction form like that. So to get rid of that decimal, similar to what we did when we were dividing decimals, we're going to multiply or move the decimal point over. There are two decimal places here, so to get rid of the decimal, we would have to multiply by 100. That would make that 5,625. So, of course, that means we have to multiply the other number by 100 as well. 100 times 100 is 10,000. Now we need to reduce. Now, looking at that, I'm sure you can see both of those divide by 5. If you look a little closer, you can see they both divide by 25. So 5,625 divided by 25 is 225. 10,000 divided by 25 is 400. Looking at those, you can see that they can still be divided by at least 5. Looking closer, again, you can see they can both be divided by 25. 225 divided by 25 is 9. 400 divided by 25 is 16. So that percent, 56.25%, which remember that means 56.25 out of every 100, is the ratio 9 out of 16. We might have 36 2/3%. Again, if I want to convert that into a ratio or into that fractional form, it is 36 2/3 out of 100. Now, just like up here where we didn't like having a decimal within that ratio, we don't like having other fractions within our ratio either. Kind of like fractions within fractions. We want to reduce those out. There are a few different ways to get rid of this. I'll show you the two most basic ways, most common ways of doing it. One is to just divide them out. 36 2/3 out of 100 can be thought of as 36 2/3 divided by 100. And of course, to divide that, first of all, I make the 100 a fraction by putting it over 1. And then I have to turn the 36 2/3 into an improper fraction. 36 times 3 is 108, plus 2 is 110 out of 3. And the division, remember, operates on the number coming after it, so I'm going to turn that into times the reciprocal. Reciprocal of 100 over 1 is 1 over 100. Now we can cross-cancel here. Both 110 and 100 divide by 10. 110 divided by 10 is 11. 100 divided by 10 is 10. So I have 11 times 1 is 11. 3 times 10 is 30. So 36 2/3%, which means 36 2/3 out of every 100, is the same as 11 out of 30. So now again, these are often referred to as fractions, but they are a fractional form, but technically they're a ratio. Your textbook, unfortunately, does still refer to them as fractions or fraction form of a percent. So back to that 38% that we were looking at earlier, meaning 38 out of 100. In that fraction form, we can divide that out. 38 divided by 100, you get 0.38. Now, once again, many textbooks refer to this as a decimal or decimal form. And it is in the form of a decimal, but technically it is what we call a rate. Now, why is it a rate? Well, the ratio, the percent itself, is out of 100. The rate, or the decimal form, 0.38, is technically 0.38 out of 1. So it's what we call actually a unit rate, to be specific, because it's out of every 1. Now again, most textbooks refer to this converting the percent to a decimal. It is, like I said, it is a decimal form, but the technical name for it is a rate. When we go to calculate percents, they'll talk about the rate method. Well, the rate is that what most textbooks call the decimal form. So when we're going from a percent to a rate or a decimal form, we are always going from out of 100 to out of 1. So we're dividing by 100. If we think of our fractions, let's say we have 65%, which is 65 out of 100. If I want to make that out of 1, well, I look at this, 100 divided by 100 to get 1. I have to do 65 divided by 100 to get 0.65. And in that conversion, it's always going to be dividing by 100. So the shortcut that we've all been taught is to just move the decimal 2 spots. So if I have something like 79%, to convert that into a rate or decimal form, I move the decimal 2 spots to get 0.79. Or 320%. I move the decimal 2 spots to get a 3.2 as a rate, or 7.6%. I move the decimal 2 spots, and we got to be careful here, 0.076. Now here's the one that I always catch people on. So I want you to try this one. 0.5%. Convert that into a rate or that decimal form. I'll give you a second to think about it. So the big question, a lot of people say 0.5. That's 0.5 would still be a percent. It would just be as a decimal percent rather than a fractional percent. To convert it into a rate, we still have to divide by 100 to get 0.005. One of the things I talk about a lot when I do percents is something called benchmarks. We'll talk about them way more here before the end of class today. Benchmarks deal with common but very easy to calculate percents. One of those benchmarks is 1%. And as a rate or as a decimal form, 1% is 0.01. Well, if I compare that, 1% is bigger than 0.5%. So the rate of 0.01 better be bigger than the rate for the 0.5%. So when we got 0.5 for that, we know that that's in percent form. That can't be the rate. The rate has to be smaller than 0.01. So then to convert back into a percent, we take our rate. We might have 0.72. And again, remember that is 0.72 out of 1 because that's the definition of our rate or unit rate. We want to turn it into a percent, it has to become out of 100 again. So to turn the 1 into 100, we have to multiply by 100. So then we multiply the top by 100 as well. 0.72 times 100 is 72. And here we have to be careful how we word this. We want to just say, well, that's 72%. Well, right now it's 72 out of 100, which is equivalent to 72%. Technically, putting the percent symbol up here would be incorrect because it's 72. No, it's not 72% out of 100. It's 72 out of 100, which is the 72%. Now, of course, every time we convert from that rate or decimal form into a percent, we're going to be multiplying by 100. Well, every time we multiply by 100, again, the shortcut we've all been taught is to just move the decimal point 2 spots. So if I have 0.21 as a rate, that becomes 21%, moving the decimal 2 spots. If I have 1.9 as a rate, that becomes 190%. If I have 0.035 as a rate, it becomes 3.5%. So converting back again is just a matter of moving that decimal. The last conversion we're going to do is probably the most difficult one, and that is taking a ratio or fraction form and converting it into a percent. We're going to start with one that everybody knows, 3/4. Pretty much all of you could tell me off the top of your head, 3/4 is 75%. But what if we didn't know that? Well, there are a lot of processes we can do. One would be to just convert it into a decimal or a rate. 3 divided by 4 is 0.75. And then we can move the decimal point over to turn that rate into a percent of 75%. Or we could think of it as equivalent rates. 3/4 is 3 out of 4. We're converting that ratio of 3 out of 4. We want it to be out of 100. So we have to multiply the 4 times 25 to make 100. 3 times 25 makes 75. So again, we have to be careful on our wording here. That's 75 out of 100, which becomes 75%. However, not all fractions convert so easily into hundredths like that. If I had 5/8 and I want to convert that into hundredths, trying to figure out what I multiply the 8 by to turn it into 100 is not so easy. So we work backwards to figure out, rather than trying to say, what do you multiply 8 by to make 100? We take 100 divided by 8. And whatever that result is, that's what we're going to multiply the 5 by. 5 times 100 divided by 8. First off, the result here is 62.5. So that's 62.5 out of 100, or 62.5%. Now let's look more closely at what we did there, a process that you've probably seen before. Is really what happened here. The shortcut, we see that we're always going to be multiplying the two numbers that are diagonal with each other. The 5 and the 100 are diagonal. So this was 5 times the 100. And then the third number that's diagonal with the number that's missing, here the 8 was diagonal to our missing number, we end up dividing by that number. So 5 times 100 and then divided by the 8 gave us the 62.5. So if I have 2/5 as a fraction or ratio in that fractional form, and I want to convert that into a percent, I know it's going to be out of 100. I just cross multiply. So now look at the two numbers that are diagonal are the 2 and 100. So that's 2 times 100 is 200. And then the number that's diagonal to our missing number is the 5, so I divide by 5. The 200 divided by 5 is 40. So that's 40 out of 100, which is equivalent to 40%. So that process there that we just saw, this basic proportion with cross, multiply, and divide, is going to be very important for our basic calculations coming up in just a minute. Before we hit those basic calculations, though, I want to come back to what I had mentioned before, that idea of benchmarks. Now, I'm going to start with a relatively large number here just to make it simple. We're going to have 580 is our number. This numbers are starting out, this is our whole number. It's referred to as the base amount. And technically, it represents the full thing, or 100%. If I want to look at smaller percents of that, the benchmarks I'm going to look at, one of them is going to be 10%. Well, 10% is 1/10 of 100. 10% of 580 is 1/10 of 580. Well, we know that dividing by 10, you just move the decimal point a spot. So 10% of 580 is just going to be 58. So that is one of our benchmarks. 10% is a pretty easy percent to quickly calculate. The next is 1%, or 1/100th of 100. 100th of 580, again, dividing by 100, we just move the decimal point 2 spots like we did up above. That would be 5.8. So now these benchmarks serve two purposes. First of all, if I am trying to find 8.3% of 580, I know that 10% is 58. So that means 8.3% is smaller than 10%. My answer here better be slightly smaller than 58. So we can use these benchmarks as a way to double check our calculations. Kind of like we talked about last week, Wednesday, of estimating our answer before we plug it in the calculator. That's one of the things these benchmarks can do. Just have that little bit of forethought before we punch it in. But we can actually use these benchmarks for calculating some simple percents. If I ask you to find 12% of 580, well, I can express 12% as 10% plus 1% plus another 1%. Well, 10% was 58, 1% is 5.8, and another 1% is another 5.8. So here, 10% plus 1% plus 1% is 12%. We add up here, 8 and 8 is 16, so 6 carry the 1. 9, 19, so 9 carry the 1. That's 69.6. 12% of 580 is 69.6. So those benchmarks allowed us to calculate, in this case, an exact answer, just with some simple addition and moving decimal points. Another example might be find 19% of 310. So here, I'm going to express 19% as 10% plus another 10% minus 1%. So over here, 10% of 310 is 31. Another 10% is another 31. Then we're going to subtract out 1%, which is 3.1. So here, 31 and 31 makes 62. 62 minus 3.1 is 58.9. So 19% of that 310 is 58.9. So you can see these benchmarks not only great as an estimating tool to estimate our answer before we punch it in the calculator, but it's also a way to actually calculate exactly some of these basic percents. All right, so now let's take a look at basic calculations with percents. Now we're going to talk about, there's a few different methods for calculating. We're going to talk about two of them. The first one we're going to talk about is the proportion method. Can't write today. Go. The second method we're going to talk about is the rate method. Now notice I'm going to be leaving the right half of my paper blank, because what I'm going to do is I'm going to come back and redo each of these examples. After I do them all with the proportion method, I'm going to come back and redo all of them with the rate method. So the first example I'm going to put up here is find 35% of 64. So when we're working with percents, we always want to start with the percent. Here the percent, 35%. So for the proportion method, we're going to turn it into that ratio of 35 out of 100. Now, before we do the rest of this proportion, there's going to be another half over here. Let's talk about what the 35 and the 100 mean. So when we're dealing with percents, there's always two things that we're focusing on. One of them, the 100, is what we called that base amount. Remember when we talked about benchmarks, that base amount, that was the whole thing, or the amount that the rest of our calculation is being based on. That's why it's called the base amount. It's the basis of our calculation. It is what the percent is taken from. The 35 here then is often referred to as the portion of interest. It is the piece of that base amount that we're focusing in on. Now I say piece a little tongue-in-cheek because sometimes that can be larger than the base amount if our percent is bigger than 100%. So over on the other side over here, we have to make sure we match things up. First of all, we're asked to find 35%. That implies that what we're trying to find matches up with the 35. The wording here of 64 can often be read as out of 64, implying the 64 goes on bottom. And now to calculate, we do what we were doing above to convert our fractions. We cross, multiply, and divide. So we find the two numbers that are diagonal with each other. That is the 35 and the 64. We multiply those, 35 times 64, giving us, that's too early in the morning for that one, 2,240. And then the number that's diagonal to our missing number is the 100 here. We divide by the 100, giving us 22.4. So 22.4 is 35% of 64. We might have blank is 160% of 45. So here again, we start with our percent. We have 160%. That is 160 out of 100. Now here's, like I mentioned in the first example, sometimes the percent is bigger than 100%. So here the portion of interest is going to be larger than the base amount, but we're still going to set it up exactly the same way. So blank is 160. That implies our missing amount goes with the 160. So the blank goes on top of 45. Again, we can read that as out of 45. So the 45 goes on bottom. Once again, the numbers that are diagonal is the 160 and the 45. So 160 times 45 gives us, is that 72, I believe? 7,200. Oops. I'll double check it. It is 7,200. And then the 100 is diagonal to our missing number, so we divide by the 100, giving us 72. So that is saying 72 is 160% of 45. We might have something like this. 80% of 60 is blank. Again, we start with a percent. 80%, 80 out of 100. Now on the other side, this is worded very different from our first two examples, but the setup becomes the same. Of 60 can be read as out of 60, so that means the 60 goes on bottom. 80% is blank, implies the blank match, the missing number matches up with the 80%. So again, we find the numbers that are diagonal. That's 60 and 80. We multiply those to get 4,800. 100 is diagonal to our missing number, so we divide by the 100 to get 48. That's 48. 80% of 60 is 48. So now, even though each of these first three examples were worded differently, the third one very differently, all of them involve the same calculation. We were given the percent, and what we were given here was that base amount. We were looking for the portion of interest. So let's change that up a little bit. So now we're going to say something like this. 42 is 60% of blank. So we still have our percent. 60% is 60 out of 100. On the other side now, 42 is 60%. That implies that the 42 matches up with the 60. Of blank, again, we can read that as out of blank. That implies our missing number goes on bottom. So now our numbers are in different locations in our proportion, but the calculation is still the same. We find the two numbers that are diagonal. In this case, it's the 100 and the 42. The 100 times 42 is 4,200. And then the number that's diagonal to our missing number is the 60, So we divide by 60, giving us 70. 42 is 60% of 70. We might have 85% of blank is 34. So here again, we have the percent. 85% is 85 out of 100. Equals. Now again, we have to be careful to match everything up. Back here. Of blank, again, can be read as out of blank, implying that missing number or the blank goes on bottom. 85% is 34, implies that the 34 matches up with the 85. So again, we find the two numbers that are diagonal to multiply. 100 times 35 is 3,500. And then the third number, the number that is diagonal to our missing piece, is what we divide by. So 3,400, I should say. So I wrote 35 down here. This should be 100 times 34 to get 3,400. 3,400 divided by 85 is 40. So 85% of 40 is 34. Now, once again, these last two examples worded very differently, but in both cases, we had the percent, and then we had that portion, the portion of interest rather than the base amount. But we just had to match everything up in the proportion and cross multiply and divide. And our third type of problem we can run into is something like this. 27 is blank percent of 90. Here we're missing the percent. Now, in all the other problems, I started with the percent, but here we don't have it. But it doesn't matter. We're still going to start with the percent. It's just blank out of 100. We don't know what this number is. In this problem, that's what we're trying to find. On the other side, 27 is blank percent. That implies 27 matches up with that missing number. Of 90, again, read that as out of 90, implies the 90 goes on bottom. So here again, we have a different setup. We have the numbers in a different positions in our proportions, but our calculation is still the same. We find the two numbers that are diagonal. Here it's the 127, and we multiply them. 100 times 27 is 2,700. And then the third number that is diagonal to the missing piece is what we divide by. 2,700 divided by 90 is 30. So that is 30 out of 100, or 30%. So 27 is 30% of 90. We might have blank percent of 120 is 60. Again, we're missing the percent. So we're going to start out as blank out of 100. That missing percent is what we're looking for again. On the other side, of 120 can be read as out of 120. Implies the 120 goes on bottom. Blank percent is 60, implies the 60 matches up with our missing percent. And again, we find the numbers that are diagonal. That's 160, and we multiply those. 100 times 60 is 6,000. The number that is diagonal to our missing number is the 120. We divide by the 120. That gives us 50. So 50 out of 100 is 50%. So that is the proportion method for calculating percents. I like the proportion method for a lot of reasons. One is you just got to match up the numbers. From the percent, you match up the numbers, and then it's just cross multiply and divide, just adjusting to where the position of the numbers are in the proportion. It's also nice because when we hit word problems, that matching up helps us make sure we're doing the calculation correctly. For example, FMD Corporation estimates weekly profits as 12% of net weekly sales. find the net sales for the week. Where profit is estimated at $648,384. So let's start out with that percent, 12%. 12 out of 100. But before we proceed, let's look at what each of those numbers, the 12 and the 100 in that ratio represent. The 12% is the weekly profit. More specifically, it's the estimate of the weekly profit. The 100%, the base amount here is that's estimated out of net weekly sales. So now when we set up the rest of this proportion, whatever goes on top has to also represent the net profit, the weekly profit. Whatever goes on bottom has to also represent the net weekly sales. So we look at this number here, 648,384, that represents profit estimate. So that is the estimate of the weekly profit. That has to go on top. So 648,384. And then we cross multiply and divide. 100 times 684,000. 648,384 divided by 12 gives us 5,403,200. So many people would have looked at this problem and saw that this is a large number, and they would have thought, well, we got to make that smaller. But by matching things up with the percent, using that proportion, it helps us keep everything in the right place and get the correct calculation there. So I promised I would go back and show you the rate method as a second method of doing this. So the rate method involves converting the percent to a rate. So for this one here, we have 35%. As a rate or a decimal form, that is 0.35. Next, it involves, the next step depends on what we are given. Here we are given the base amount. So since we're given the base amount, our calculation is the base amount times the rate. So we take that base amount of 64 times the rate of 0.35. That gives us 22.4. Now that might seem to be like it was simpler and quicker and easier than the proportion method. And for this problem, it was. Let's go to the next one. Here we have percent of 160%. We convert that to a rate, which is going to be 1.6. We take our base amount of 45 times the 1.6. It gives us 72. Seeing it short like that definitely looks a lot quicker and easier. The next problem, we have a percent of 80%. As a rate, that's 0.8. We have our base amount of 60 times 0.8 gives us 48 as our portion of interest. So for those first three problems, this rate method looked pretty good. And it is. It's pretty simple. But it's really only simpler for problems where we have the percent and that base amount. This next problem here, we do not have the base amount. Here we are given the portion of interest. And when that's the case, we take that portion of interest divided by the rate. So we have our percent here, 60%, converts to a rate of 0.6. We take our portion of interest of 42, divided by 0.6 to get 70. Now again, that calculation is fairly simple, but we had to look at the problem and decide here, are we multiplying by the rate in this case, or are we dividing by the rate? Next problem here is the same thing. We have 85%. That converts to a rate, 0.85. So we take our portion, 34, divided by 0.85, and it gives us 40. And then a third type here, where we are missing the percent. And in that case, what we do is we take the portion of interest divided by the base amount to get a rate, and then we have to convert it. So here we have 27 over 90 gives us 0.3, and we convert that to 30%. So as we look through this rate method, yes, it is quicker. And if you're just doing it on the calculator and you don't have paper to write it down, the rate method is more conducive to doing that quick calculation on the calculator without paper to write out the proportion. But I've found it makes students make a lot more mistakes using the rate method because, well, you have to make that decision. Am I multiplying by the rate or am I dividing by the rate? Or am I missing the rate and I have to divide out two numbers to get the rate and convert to the percent? With that said, now there are applications like interest and commission and stuff like that, and we're going to look at solutions, concentrations, and mixing solutions, where it's just the rate, because we are always given the base amount, that rate method is just quicker and easier to put into a formula, so it does get used quite a bit. A third method would just be an algebraic method or the equation method. And the equation method basically it's just taking the rate method and putting it into a single formula where it says that portion of interest is simply equal to that base amount times the rate. And then we plug in the numbers and solve the equation. Like I said, in Unit 2, we're going to look at percents a lot more. And we're going to look at actually investing in interest with percents a little bit. Just because I feel like, especially working with younger students, it's good to see how interest affects your life as you at the young age. For right now, we'll give you some homework. In your book, it is page 36 through 37. 1 through 51, the odds. Again, I realize that is 26 problems. I don't expect you to do all 26 problems, but look and make sure for each section, do a couple of the more difficult problems at the end, and then make sure you do the word problems again, because that's where I find that students have the most difficulty. The tests are at your location for next Wednesday, so I've already received confirmation, so we're ready for that. Next Monday, we'll finish up Unit 1. Next week, Wednesday, I will be on the network for you, so you can log in if you have questions as you take the test. But just, again, be prepared. Next Wednesday is our Unit 1 test. And for any stress out there, you are allowed to use your book and your notes on the test. You are allowed to use your calculator, but there are the first 13 problems you must show your work. And that's what we've discussed as we go through the unit here, those steps of setting up the problem, doing any carrying or common denominators and stuff like that. So with that, that's our time. I'll let you guys all go. Have a great weekend, and we'll see you all on Monday.